We're going to take a look at highest common factors, also known as greatest common divisors in America, I believe. The highest common factor, what is it? It's a factor that two numbers have in common, which is the biggest factor that the two numbers have in common. Let's take two numbers like 24 on the one side and 30 on the other side. I can think of a factor, 2. That is a factor that goes into 24 and 30, but it's not the biggest common factor. It's not the greatest, the highest common factor. How might I find the highest common factor with a method that would work for any number, big or small? Here's how I would do it. I would do a prime factor tree. If you're not sure how to do that, I've got another video on prime factors showing how to do that. For now though, we're just going to go ahead and do the prime factor tree. 30 can be split up into 3 times by 10. 3 is a prime factor because it's a prime number, so I'm going to circle it. 10 is not, it can be split down into 5 times by 2. And both 5 and 2 are both prime numbers, so I can circle both of those. I'm actually also going to fill them in because I think it looks lovely. Whoops-a-daisy. Okay, there must be a gap there somewhere. Let's fill that gap in and fill. No, never mind. I won't fill that one in. But 3. You know what? Let's do another ring round. And finally, we have 2. They are the 3 prime factors of 30. Let's quickly do 24. 24 is 12 times by 2. 12 is 6 times by 2. And 6 is, of course, 3 times by 2. And now we've broken it down as far as we can go. So let's circle those prime factors. 6, of course, is not a prime, so we're not going to circle it. Prime number is a number that cannot be broken down any further. And we're even going to fill those in if it works. What we can do now is use our brilliant method for finding the highest common factor. At the moment, you're probably wondering, how does this actually help me find the highest common factor? What you've just done is show me the prime factors. Here's how it works. You have to be very careful and you have to write one number on top of the other number. Then you write out the prime factors in the special way that I showed in the other video. Instead of writing 3 times 3 or 3 times 2 times 2 times 2, you write 3 times 2 cubed. 2 cubed. Now, again with 30, we're going to write it underneath. But here's the secret. We have to put the 3's beneath the 3's, the 2's beneath the 2's, and the 5's beneath the 5's if there were other 5's. We can't mix around the order, otherwise this method won't work. In that case, we're going to write 3, then the 2 after it for 30, then the 5 after that. We've kept the columns nice and neat with all the same numbers in the same column. It's really important to remember that detail. It's really important to, first of all, remember to write them one on top of the other, and second of all, I might even write a little hint. 1, first thing, on top of each other. Spread that out. Second thing, in order, which means the 3's with the 3's, the 2's with the 2's, the 5's with the 5's, the 7's with the 7's if there were, etc., etc. Now here's the killer bit. For the highest common factor, beneath, you take the smallest of each of the numbers. In the case of 3 and 3, they're both the same size, so we just take 3. times by, this is highest common factor, HCF for short, for 2 and 2 cubed, which is smaller? 2. Now you might want to put 5 there, but it's 5 and nothing. And what's smaller? Nothing. So we just leave it out. Indeed, the highest common factor, therefore, is 3 times 2, which is 6. Now we could do one more quick example of that. We're going to do it ultra fast, and just to bed down the idea of the highest common factor or the greatest common divisor. Let's do some slightly harder numbers though. Let's do 72 and 54. Now you might be wondering, why are they actually useful, getting highest common factors? I'll show you at the end, but what they can do is simplify fractions very quickly and very easily. Now I'm going to do the split 72 into 8 and 9. I'll draw the lines later, 8 and 9. 8 can be split into 4 and 2. 9 can be split into 3 and 3. And finally 4 can be split into 2 and 2. If I draw the lines, it looks like that. And if I circle the prime factors, not just the factors, but the prime factors, I would circle these numbers. I would also highlight them, just to be fancy. Those are the prime factors. I'd do the same thing for 54. 54 is 9 times by 6. 9 is 3 times by 3. Don't need the times really. And 6 is 3 times by 2. Draw the lines. Circle the prime factors. And we're almost there. Let's highlight the prime factors. That's nice. And now, what do we do now? I knew we had to write it out in some way, but should I write it out? How should I write it out? Yes, that's right, on top of each other. So 72 is 3 squared. I could write 3 times 3, but for this method, let's write 3 squared. And 2 cubed. 54 is... Now, I'm going to write 2 times 3. No, I remember what that guy said. He said, write the 3's beneath the 3's, the 2's beneath the 2's. So I'm going to write 3 cubed first of all. Then I'm going to write the 2 over here. For some reason, I had to have them in order. That's correct. For the highest common factor, if I can just about fit it on, HCF, we're going to do the smallest of the two numbers, not the biggest, the smallest of these two numbers in these columns. What's smaller, 3 cubed or 3 squared? 3 squared. So let's write 3 squared. And what's smaller, 2 or 2 cubed? It's 2. That means the highest common factor must be 3 squared times by 2. 3 squared is 9. 9 times by 2 is 18. A quick insight as to why that might be useful. If you had a fraction like 54 over 72, some people might give up in terms of simplifying that, but you could do it in one stroke. You'd find the highest common factor, which is 18, divide the top by 18, divide the bottom by 18, 54 divided by 18 is 3, 72 divided by 18 is 4, so straight away you've got to the simplest possible fraction of 54 divided by 72, which is 3 over 4, and that's part of the beauty and power of highest common factors.